Hello everyone, welcome back to my channel. My name is Toby and this is Promoting Safety Engineering where we do everything safety, safety, safety. This is a continuation from the video talking about blowdown and depressurization. So this is a continuation and the first in the series is the fire and gas detection video, followed by the depressurization and shutdown, and then followed by this, which we will be talking about marking up your isolatable sections. Okay, I'm gonna explain all that. But before we go much further, of course, like the video, subscribe to the channel. All we do is safety engineering, process safety, loss prevention, and yeah, I'm a safety engineer. So let's get into it. So the reason why, I want to explain why we're doing this. It's for your QRA, which is your quantitative risk assessment. I guess I should do a video talking about quantitative and qualitative risk assessments and semi-qualitative quantitative risk assessments to explain and break them down so you have kind of an idea where I'm going. But so this step I want, because I can't teach how to do a fire and explosion risk assessment or quantitative risk assessment in one video. It would just take forever. So I'm breaking it down into little chunks and you so that you kind of grasp the entire idea and how it all leads into your safety case. So I'm breaking it down into little chunks, how you can do it, do work on each part, and to understand the importance of each part. So of the job. So this we're going to be marking up isolatable sections, and that's why the video before this is talking about depressurization blowdown, because what we want to be looking at is on fire detection when your valves, your shutdown valves close and your BDVs open, your blowdown valves open up, what's the inventory that is locked into here? And what's the risk that we can get out of that isolatable section? What's locked in? We want to know, have an idea of how much liquid, how much gas is going to be trapped in the system. We want to know the risks associated with all the equipment, every single equipment, the valves, the valves, the vessels, the fans, the compressors. We want to know like what are the risks they pose, what is their failure rate, what's how hot. We want to know that that liquid trapped in here, gas, how long is it gonna burn, because we're gonna use all this in our simulation. How long is this fire gonna be for? How long is it gonna take before you blow down to you should hit your half of the pressure in a certain amount of time? And we want to know all that by first calculating what's in your isolatable section, what part. So, okay, so what's the isolatable section? It's just saying that when there's a fire or an explosion, you're gonna have to isolate, and which means your shutdown valves are gonna close. So when that happens, you want to know what's in there. So we're going to isolate this system. And so this is just looking at 3 P&IDs. You may have, like for a facility, you may have 20, 50, 100 P&IDs. So you're going to break, you could have done FERA's fire and explosion risk assessments with over 50 isolatable sections, because you have to mark them down in chunks. Now it's going to be kind of like marking up hazard nodes, but it's a little more technical because we want to look at every equipment, every instrumentation in this entire in that isolatable section. So let's say we're starting from somewhere here, whatever. So the way you mark up isolatable sections, you look at shutdown valve to shutdown valve. So, because when all this close, you want to have an idea what's going to be sealed inside here. You look at shutdown valves to shutdown valves, up to the PSVs, your pressure safety valves, and up to your BDVs, everything in here. You want to have an idea. So, let's say this is another isolatable section we're coming from. So, as I'm going in, I would be explaining. No, I didn't want to do that, but yeah. So let's say we look at this. So this up to this shutdown valve, let me, so this is how you mark it up. Um, yeah, thickness, you can make it up to 6, and then you can make it 50, right? Make the opacity 50 so you can kind of see through it and have an idea of what's under. So that's one. So probably there's some equipment upstream before this shutdown valve. All that is one isolatable section. So we're starting from this, and I'm just going to mark up one, but I guess I'll explain it's detailed enough so that you kind of have an idea what it is. Then let's come here. So this is another, so we start a brand new isolatable section from here, but of course I'm gonna have to work on this for a while. I want to change the color because it's good to change the color so that you kind of it's good to change the color so that you don't mix up isolatable sections. Okay, so this is blue here. So you're gonna mark up everything. And let's go to yeah, let's go to the top. In a HAZOP, you wouldn't normally do this. You wouldn't mark up. So I'm just explaining. I guess I should talk a bit. You want to mark up everything around it. This is different from a HAZOP. Remember, it's not the same as a HAZOP. You want to mark up everything around it because you're looking at if whatever is trapped in here, you're looking at the risk of everything involved. So when we're doing our parts count, we're going to look at all this. All this are going to have, should I say, connections to instrumentations, which are all leak sources. All the valves, they all have failure rates. We're going to pull them up and look into them. So from here, this is part of, we'll continue with our isolatable section. Start from the compressor here. I'm just gonna go backwards. Normally I should go forward, but hey, this is how it flows. Come in here, and you have to be very, have to know what you do. Sorry, that was not what I meant. To look this way and look this way. So that's another. So I would explain why we're doing all this, but okay. So this leads to your PSVs, and you're gonna in a HAZOP you wouldn't mark this up, but here for your isolatable section you kind of have to mark it up. Oh, okay, I don't like that. Delete. Let me use this. Okay, then we come from here. So you go all the way up to your PSVs. You want to make sure that you mark all the way to the valve or the flange just before your PSVs, because this wouldn't pop open if you have a shutdown unless things get crazy and out of hand. Okay, this is locked close, but normally you want to make sure that it's really maybe like the tight TSO valves, like tight shut-off valves. But just for the sake of this, we'll look at it up to here, up to here. So we're marking up the isolatable section. That's it. You're doing it. We're doing it together, right? Yay! I'm gonna still mark up this compressor all the way around. Okay, that's a locked closed. When you see LC, that means locked closed, and when you see NC, that means normally closed. And then you want to mark it up again, here to here to here. You want to mark this tiny part up from here to here. All these little parts should all be marked up. I'll delete this. This shouldn't really be in there, but yeah. Okay, up to this valves up. Okay, so we continue here all the way. So this line, I'm gonna trace it. So you can see that this is ends in 1143, and this goes to train 2 compressor K21101. So it goes to another compressor because we're marking down shutdown valves to shutdown valves. So I'll come from here, go this way up to this shutdown valve, this flange just here, because that's where everything that's as far as the crude goes, right? Or the gas goes. You want to mark up everything because you want to look at all the valves around and stuff like that. Okay, can I use this? Yeah, I think I'll just make a quick one out of it. I don't want to dwell too much in this. So, okay, we still have this here. Everything has to be cut because need to mark it up really well. This line comes from here is just the line for that controls the compressor. If it sees a lot of feed here, it would speed up, and if the feed is too low, it just controls the compressor so it doesn't suck. It doesn't suck too much. Should I say, which controls the compressor motor, compressor motor, so that you don't, should I say, if the pressure here is low, it doesn't work too fast, and if it's the pressure here is high, there's a lot of gas, it works faster, so that you're not just pulling and creating a vacuum. So that's what this is kind of controlling. It keeps that back pressure here that controls that valve. It's so I would take where's the, okay, sorry, this is a pressure control valve, so that's a pressure control valve, so you don't want to come here and come here. You don't want to overwork the pressure control valves. Okay, yeah. So let me see everything I have in here. So this, oh, I didn't look at my liquid leg, sorry. That's a DBB arrangement, double block and bleed. And then you have this from here. Remember, this is a control valve. You don't want to worry yourself with that. Yeah, everything's up to here, blocked up. So this, then, okay, I said I was going to tell you where this was going to. 11, 4, 3, 2, going to another train. So we go, that's page, that's the next page. So if you're looking at this line, that's 11432. Yeah, I think that's it. 11432. Let me just be sure. Yep, 11432. 112 11432. Go to the last page. 1112 11432. So we come to the last page and we look at all the way. So the isolatable section still continues till you see another shutdown valve. So you just go on from there here, go on here, come here, come up, come up, come up, go up, go up, go up. Then you come from here, take this to here, take this to here, take this, and I know the valve somewhere here. So this is the next shutdown valve. I don't think I saw any shutdown valve before that. So although this is locked closed though, so actually this is where I should have stopped. Yeah, this is actually where it stops. This starts another isolatable section. This right here starts another isolatable section. So this from here is part of the old one. So that was just a little mistake because these valves are all closed, locked closed. So this is another isolatable section. Let me change the properties of this and change it to what am I going to make it? Someone give me an idea. Purple is fine. Yeah, we have red, we have blue, and we have purple. Okay. So now we've marked up the isolatable sections. This is very important. So what we're gonna do with this is we're saying that when there's a shutdown in the system, at least on paper, what we're gonna be having is when this would close, this would close, this would close, this would be closed, and the ones just after here, which are on page 3, would be locked closed. So that's one isolatable section we have. So what we are now going to calculate is the amount of inventory we're going to have in here. How much fluid, how much liquid, how much gas. And the way we start that is what I'm going to fully explain in the next video. So but just to give you a clue, we're going to look at this line to this line. We'll write it down. This line all the way to this line, we write it down. This line to this line, we write it down. This equipment, we write it down. This line to this line to this line, we write it down. Everything, every line, this line here, we write it down. This line here, we write it down. This line, everything, we would write it down. And based on the size of the line, like this is probably 150 millimeters. Is it millimeters? I'm not sure. I'll have to check, but it can be inches because there's no 150-inch pipe. So probably, yeah, 100 millimeters would be how many centimeters? That would be 10 centimeters, which would be about 3 inches. So probably this is like a 3-inch line, and this 150 millimeters would be about 15 centimeters, and that would be about 6 inches. So this is a 6-inch line. So with that, you would calculate the length of this line. You can run estimates, or you can do actually what we call you can run estimates, or you can actually pull up the ISOs. You can have your isometric drawings, and you would pull them from your model. You would get them from piping, the model, and get all this line sizes. You type in this line into what's it called? Either Freedom, Navisworks. you pull up the line and you get the length of this line, and you calculate that length with the volume. We use that length and the diameter of the pipe. This we said probably 6 inch. You use that to calculate how much liquid or how much gas would be trapped in here, the volume. You'd use that to calculate everything. And when you finish doing that, so for each line, for each of the equipments too, you'll get the sizes from here, this by this. And when you get that size, you get the sizes of all the lines, and you calculate the volumes inside every single line, equipment, and vessel. And you put it all on a sheet and you calculate that and you get an answer. And yes, this is what we have in this isolatable section. This is the amount of liquid we have in it. Because when you put it into like softwares like Fred or Fast, you want to calculate how quickly you would have your blowdown. When this blowdown opens, how long is it? How long is it going to be before the gas blows down to maybe 1 bar or 2 bar? Maybe you have gas here that's maybe 10 bar, although we know here it's much less than that. But you want to have an idea how long it would take for the because you're going to do blowdown calculations with the software. You can also do them by hand, and you want to have an idea of everything in here with the heat and material balance to know how hot the fire is going to burn, how long the fire is going to burn, how far the fire is going to burn based on the pressure and the leak size and that kind of stuff. So yeah, I think I know that there'll be lots of questions, but I think as I go further in the series, some things will get clearer. But you want to mark up isolatable sections, and you could have a lot. Like with this is one, you'll probably have another one here, starting from that shutdown valve, and you calculate this probably as another, because you had this shutdown valve here. So okay, this goes to the drain. Where does this come from? I'm not too sure. I'll look into it. 134111. Probably here. Yeah, this is it. 134111. This is where another isolatable section starts from, and it goes from there all the way to here, all the way to here. So this is another isolatable section, and this is the only equipment in here. Although you have all the valves and instrumentation, you want to calculate that too as another isolatable section. You add up every line and you calculate what you have in there. Then we would now go into the should I say what's it called? Getting the but no, we would get up the sheet where we would pull up all the lines and everything, all the equipment in here, and the isolated and the volume of what we have in here, and then yeah, okay. So thank you very much for watching. This is Promoting Safety Engineering. This is Toby. Please like, subscribe, and do have a lovely one. Thank you. Bye bye for now.